Good afternoon, good afternoon, good afternoon. We are moving on to geomorphology now on the 2025 paper, Geomorphology. What is it that we have here? Complete the statement in column A with the options in column B. Write only Y and Z next to the question numbers 2.1.1 to 2.1.8 on the answer book, for example, 2.1.9Z. So what do we have? So when it comes now to geomorphology, guys, especially now in grade 11, what have you covered? Remember, you covered the horizontal layered stratas, which covers part of your hilly landscapes, your, what else did you cover? Your canyons, your basaltic plateaus. What else did you cover? You also covered the Karoo landscape. You also covered the inclined landscapes. Okay, looking at different coasters. So your coaster, it falls under the inclined rock strata. So when it comes to a coaster, it's more a ridge that is made up of a deep slope and a scarp slope. I will demonstrate what I mean by that. So this is your deep slope, and this is your what? Your scarp slope. This is what makes a coaster. This is what makes a coaster. It's a ridge that is made up of a deep slope and a scarp slope. A scarp slope, a deep slope, this is your deep slope. Okay, your deep slope. So your deep slope is gentle and your scarp slope is steep. That's how you can actually differentiate the two. This is steep, this is gentle. As your deep slope, this is gentle. That is the difference between the two. Your deep slope is gentle and your scarp slope is steep. So that's what differentiates the two. So this is an example of a coaster, so it means we differentiate these ridges in terms of the angles. Of course, from your coaster is between 10 to 25 degrees, the angle of inclination. That is your coaster. This is your coaster. The angle of inclination is what differentiates the different ridges or the different inclined stratas. Okay, that is your coaster there. Then we have got the other one that follows now, which means the angle of inclination have changed, but we still have the dip. We still have the what? The scarp. We still have the scarp. So this one, it ranges from 25 to 45 degrees. That is your homoclinal ridge. That is your homoclinal, okay, ridge. Okay, the only thing that is that actually differentiates the two ridges is the angle of declination, the angle of tilt. Here on your coaster is 10 to 25 degrees, then on a homoclinal ridge is 25 to 45. Okay, that's what differentiates the two. Then the last one, you are not likely to see a much difference between your dip, okay, and your scarp slope. Okay, this is now your hawk's back, okay, this is your hawk's back, another ridge. Okay, this one is more than 45. This more than 45 in terms of its inclination is more than 45. It's more than 45. So you've got your coaster 10 to 25, your homoclinal 25 to 40, then you've got your hawk's back that is above 45 degrees. So what differentiates these ridges is the angle of inclination, the angle of inclination on your deep slope. You can see here 10 to 25, years 25 to 45, years above 45. So that's what differentiates the different ridges in as far as the inclined rock strata is concerned. So that's how you do it. Okay, this is how it actually differs. Okay, so the first thing is coasters are found in topography associated with, obviously, I've already said it. This is inclined layers. That's your coasters. The length from where the layers dip at 25 to 45. Okay, I've already talked about it. This is your homoclinal ridge. That is your what? Homoclinal ridge. Then the breaking down of rocks due to extreme temperatures. That is your mechanical. Think about your mechanical. It is also known as physical weathering. Mechanical, which means the rock expands. When it expands and contracts and expands, temperatures are high, rock expands. Temperatures are low, the rock contracts. So constant expansion and contraction of rock result in the breaking down of rocks because of this extreme temperatures, high, low. So that is your mechanical. When you talk about chemical weathering, we are talking about the changes that take place as a chemical reaction between, of course, let's talk about hydrolysis. Water action, okay, when the gets in contact with water, rocks are made up of different minerals, so they react differently. They are chemically eroded. That's basically what I'm saying. Soil becomes saturated and slides over a frozen ground beneath it. This is a form of mass movement. That is your solifluction. Solifluction. Soil creep is associated, on a slope that is made up of soil. Of course, the high temperatures and low temperatures cause the soil on the slope to expand and contract, which can result in each moving down the slope. That's part of your soil creep. The steep slope faces inwards in the center of the dome, and the deep slope faces towards the when it comes now to questas, we have got what we call the Cuesta dome and the Cuesta basin. So when it comes now to the Cuesta dome, think of it like this. Obviously, there's more like a fold that takes it, a dome. We may think about, more or less like this. So we are going to have something like this, which means this part becomes our deep on a Cuesta dome. This one becomes our scarp. So you can see in terms of position, where is your deep? Your deep is outside. Where is your scarp? Is inside. That's basically what we're talking about when it comes to Cuesta dome. When it's a basin, it's more like this, which means you look at it like this. Where is your deep? Your deep, you can see, is inside. That is your deep slope. Then your scarp is outside. Your cup is outside. So that's how you look at it. That is your Cuesta dome. What it's going to look like, that is your Cuesta basin. So the question is saying the scarp slope faces outwards. The scarp slope faces outwards. You can see here, the scarp slope faces outward 2.1.5. 2.1.5. The scarp slope faces outwards. Faces towards the center of the dome, and the deep slope faces towards the outwards. So the deep slope is outwards, the scarp slope is inwards, so which means it becomes your Cuesta dome. That's what it is. Cuesta dome, deep slope outwards, this one inwards. That's what it is. Mushroom-shaped intrusion of magma. So here we are saying now, when you talk about this, we are simply saying that during the process of volcanicity, what are we likely to have? We have got the landforms that are formed within the crust, that we call them intrusions. That we call them what? Intrusions. There's something that I want to show you. So like your batholith, your laccolith, this is basically what we are talking about. This is still beneath or underneath the crust when volcanicity has taken place. So we are saying now this is what is likely to happen. We have got the material that has moved, molten magma that has moved from the mantle, but when it moves slightly below the crust, what happens is it solidifies. As it solidifies, it results in different intrusions. So that's when we have got the batholith, you have got your dike, you have got your laccolith, you have got your seal, you have got your also what you call the lopolith, which is more like saucer-shaped. These are the different intrusions that are formed as a result of molten magma moving from the mantle and slightly below the crust. These are what we refer to as intrusions. When they're extrusions, which means they are formed on the earth's surface, that's what we refer to as extrusions. Let's move on now. So the first question reads, mushroom-shaped intrusion of magma. That is your what? Your laccolith. It's mushroom-shaped. This is the one that we are talking about. You can see the way it's shaped. That's your laccolith. Then vertical intrusion along sedimentary rocks. Vertical intrusion, that will be your dike. Vertical intrusion is along sedimentary rocks. It means they are in layers. So it's what? That is your dike. That is your vertical intrusion. Then the last one, the factor that distinguishes questas from homoclinical ridges. Remember, I have said that for you to know that whether it's a questa, it's a homoclinical, or it's a Hawksbeck, you look at the difference in terms of angle of inclination. This one is 10 to 25, this one is 25 to 45, this one is plus 45. This is what helps you to differentiate. So the answer there is angle of inclination. Let's move on. The next question reads, refer to the sketch below showing slope elements and answer the questions that follow. So when it comes to the slope elements, what you need to be aware of, guys, is you need to be able to label the different elements. Yes, you need to be able to label where do you have your crest, that is your crest here, Where do you have your cliff? That is your cliff here, or your free face. Okay. Where do you have your talus? That is your talus there. Where do you have your pediment? That is your pediment there. That is your pediment there. These are the different elements of the slope. You should know the description and the characteristics of each and every element of the slope, like I'll just say in short. So if you look at your crest, it is found at the top of the slope. That's why you see it is found at the top of the slope, which could be a mountain or a hill. It is convex in shape. When you talk about something being convex, we are saying it's going to have something like this, starts off a flat, then it goes like this. That's convex. When it's concave, obviously we have got something like this. That's concave. This is convex. So that's what we are referring to. Soil creep and weathering occurs on the slope under the force of gravity. Of course, when you talk about your scarp or your free face, scarp or a free face, this is B. Now what we have here, it is steep vertical slope formed by resistant rock. So it is made up of the resistant rock where it is, okay? That's why it's not easily eroded. Erosion actively occurs, causing rock falls. Okay, it causes rock falls, which is a type of mass movement. Then what is the base of the cliff can be covered by material deposited, okay, from the crest. That's what happened there. Okay, so what do you have in as far as your talus is concerned? It is what? A sharp break in the angle between the talus and pediment is called a what? A neck point, a sharp bend. A sharp break in the angle between the talus and the pediment is called what? A neck point, which means what separates your change in slope. That's what a knock point is between your C and D. Okay, then we have got the pediment. It is flatter slope found at the base of the angle between 1 to 7 degrees. It is concave in shape. That's what we mean when you say concave. Let's go through it now. Where the material from the cliff and crest accumulates here. Where does the measured material from the slope and the cliff, where does it accumulate? Here it's going to accumulate at C, where you've got your talus, also known as the free face. Which one is known as the free face? That is your B. Then covered with sediments from the talus. Covered with sediments from the talus. That is your D. Then is a convex slope. Convex slope. Remember, we were talking about your crest. That's your convex slope. Okay. The cliffs retreats backward due to erosion. The cliffs okay. That is your cliff or your free face. That is B. Then you've got the dominant geomorphological process taking place here are weathering and soil creep. That is also B. Weathering, which actually help in rock falls and the other stuff. Okay, that's B. Then vegetation grows better on this slope. That is your pediment. That is your pediment. Let's move on. The next one now. Refer to the sketch below showing topography associated with horizontally layered rocks. Of course, so what comes to your mind when you look at this is, let's analyze the diagram. You are seeing landform C and D, which is your mesa, which is your butte. This is your conical hill. This is more like your plateau. You only have this on a Karoo landscape. This you have on a Karoo landscape. So that's what should come your mind. You have this on a Karoo landscape. Then also a Karoo landscape, of course, it started off as a canyon landscape, then also graduated to a what? To a Karoo landscape. When we have got this landform now, we are calling it Karoo landscapes. Okay, Karoo landscape. Okay, let's go to it now. The process that is responsible for the widening of the valley, that is your scarp retreat. That is your scarp retreat. Okay, that is your scarp retreat. Then comment on the general climate of this area. You can see that it's rugged terrain. It's not smoothly shaped. So it suggests that it is a drier area. It is a drier climate with little or no rainfall. Drier climate with little or no rainfall. So that's what is it in as far as climate is concerned. Identify the landform C and D. C is your mesa and D is your what? Is a butte. That is your butte. Okay. You remember the Karoo landscape? We have got your plateau, you have got your mesa, you have got your butte, you have got your conical hill. Of course, through the process of backwesting, scarp retreat or parallel retreat, that's when it starts off as a plateau. Then parallel retreat on the sides of this landform is what reduces the width, which is the part that is made up of the cap rock. Is going to be reduced in size. It erodes the softer rock, which means the hard rock now, when it's not supported, becomes an overhang. What does it do? It collapses, which means the size is reduced gradually until we have the smaller size. Okay, let's say it starts off like this. So scarp retreat, It's happening on both sides, which means at some point we are going to end up with a landform like this, but it started off like this. So there is parallel retreat, backwesting that is happening, that reduces the size. It starts off as a plateau, then it goes to a mesa, then it goes on to a butte, then it goes to a conical hill. A conical hill doesn't have a caprock. So also for you to be able to identify that it's a Karo system, they should have the same height, these buildings. Okay, so that's it is. Distinguish between C and D. What do we have at C? The resistant top layer is wider than the height, which means here is wider, the width is wider than the height. That's basically what we are talking about. Now here the width is smaller than the height. That's how you distinguish the two. The resistant top layer, which is called the caprock, is smaller than its height. It is smaller than its height because of course cap retreat, backwesting that is taking place. Okay. Then 2.3.5, briefly discuss the impact of the utilization of these landscapes by humans. What are some of the impacts? 2.3.5. Number one, we can talk about wide flat plains between mesas and buttes are suitable for the construction of infrastructure. The holiday resorts near canyons create employment opportunities for the local people. The opportunity for a variety of adventure or ecological activities like your whitewater rafting, your abseiling, your hiking, and also use as a tourist attraction. So that's how we can actually benefit, be of utilization of significance to humans. Okay, let's move on. 2.54, refer to the sketch below showing toes. So this is your toe. What can we talk about here? What are toes? We need to know the definition. Okay, but before we do that, let's just talk in general about toes. The toes, what are they and how are they formed? Of course, you know that what happens, it's formed from the intrusive, okay, intrusive rock that forms below the earth crust. What do I mean by that? Like for example, let me talk about the batholith. There's mantle, molten magma that is gotten out of the mantle beneath, slightly below the crust, because of volcanoes, because of maybe of earthquakes. So we are saying now this is slightly below the crust. When it moves from the molten magma, moves from the mantle towards just below the crust, what happens is it's going to solidify slightly below the crust. So when it solidifies, they are vertical and horizontal cracks that form. Vertical and horizontal cracks that form, just like this. So when these vertical and horizontal cracks form, what happens? The water seeps into this batholith, okay? It seeps into this. When it seeps in this, so it means this rock is weathered chemically, which result in the shaping of these corestones along the joints, shaping of these corestones along the joints into rectangular boulders, corestones. Okay, this is what happened. This is still within the earth crust, slightly below the crust, okay, because the material, molten magma that have actually erupted from the mantle just underneath the crust is actually solidified there, which is intrusive, okay. In nature, that is your batholith. So there, when it solidifies, cracks are developing, the horizontal and the vertical cracks. So when they develop now, it means now the water will seep into the joints, which will cause the rock to be weathered chemically, result in the shaping of these corestones into rectangular blocks like the way it is now. So with time, when erosion takes place now, which means part of this will be removed, then we end up with a landform that is a toe, like what we have on this diagram, on this picture. Let's go through it now. What is a toe? A toe, what is a toe? A toe is the toes are exposed granite blocks made up of corestones or balancing rocks. That's what we refer to as the toes. Name one igneous intrusion from which toes develop. We are talking about the batholith, and the what? And the laccolith. These are the two intrusions from which the toes form. I've already explained when I was doing this. Okay. Describe the characteristics of the rock mentioned in. The characteristics is more like talking about the characteristics of the igneous rock. It's hard and resistant. Hard and resistant. Okay. The granite rock, they're hard and resistant. Of course, they are prone to exfoliation and peeling of rock layers. Obviously, what happens, the mechanical type of weathering, which means they're exposed to high temperatures, they expand, low temperatures, they contract. This is what causes exfoliation, the peeling of rocks. That's what we can talk about in as far as igneous rocks is concerned. They are prone to exfoliation, which is the peeling of rock, okay? The rocks without joints, of course, that's something that we can also talk about, okay? The last one, in a paragraph of approximately 8 lines, explain how toes develop. I'm going to explain again. So what happens in the first place is we have got the molten magma that comes from the mantle during a volcano or during an earthquake. So the material that is coming from the mantle is in molten or liquid state magma. Of course, what happens is as it gets out during an eruption of a volcano, just out of the mantle, it is in liquid state. When it gets underneath the crust, it's still intrusive. So what happens is it accumulates there, forming a batholith, okay? When it accumulates there, of course, it's going to solidify. When it solidifies, what happens is going to end up having the vertical and the horizontal cracks. That's what happened, the horizontal and the vertical cracks. Then what happens with time, the water will start seeping through the joints. When it seeps through the joints now, it means the rock now, the batholith is going to be weathered chemically, okay? I can talk of example like what we call hydrolysis, hydro-water lysis, reaction, chemical reaction between the rock minerals and the water. That's what happens. So it weakens the rock. So it means it's going now to be actually the cracks and joints, they are going to shape these costones into rectangular blocks still underneath the crust. Okay, underneath the crust. So with time when erosion takes place, it's going to be exposed. This is why it ends up with boulders like this now. But all the costones are formed when it's still within the crust. That's what happened. That's how toes develop. That's how toes develop. That's to 2.4. Let's move on to the last one. Refer to the photograph and extract below showing mass movement. Mass movement, movement of weathered material down a slope due to the force of gravity. Okay, heavy rainfall at Port St. John's has recently triggered landslides and widespread flood, causing significant damage to homes, roads, and infrastructure. Mayor Nomvuzo Sinko says she is expecting disaster management teams to arrive in the next few hours. Gift of Givers also have volunteered to help those affected by the floods. So what you need to know, guys, is this is something to do with the mass movement, of which we have got landslide as a form of mass movement. We talk about your soil creep, we talk about your rock fall. Those are different examples of mass movement that we can talk about. So let's answer now. Mass movement, the movement of weathered material down a slope due to the force of gravity. That's what mass movement is all about. From the extract, mention the factor that have triggered mass movement. That is your heavy rain. Your heavy rain has triggered mass movement. Give evidence from the photograph that landslides have taken place. You can see what is happening there. What is taking place? Roads are damaged. You can see also are damaged, have collapsed. Soil has moved down the slope. That's what shows that landslide is actually taking place. I'm talking about what is here. The roads are damaged. Soil is moving down the slope. Okay. Explain the negative impact that the landslides have on the people. What are the impacts? We are the negative impact. What is likely to happen? Houses and properties can be damaged. You can see here, houses and properties can be damaged. That's a negative impact on the people. Houses and properties can be damaged. Road closes, force road users to take long detours or long journeys when they are moving from one place to another. Underground pipes can be damaged, leading to water shortages, or when they are damaged, underground pipes, pollution, water being contaminated, and resulting in different waterborne diseases. People may struggle to access essential services, people may get injured and even lose their lives. So that is for 2.5.4. The last one, suggest 3 strategies that can be put in place to minimize the impact of landslides. What can we put in place? We can say elimination or restriction of activities along slopes. We are trying by all means to discourage people to have activities along the slope because there is a challenge that we are likely to have landslides, okay? We can also do what we call afforestation, plant natural vegetation on slopes. It helps to hold the soil together. We can also use engineering techniques to prevent landslides. We can also reduce deforestation. Let's plant trees instead of cutting down trees. We can also drainage and runoff channeling structures to remove excess water. We can also raise awareness about landslide risk and how to respond. We can help communities to prepare for and minimize potential damage. We can also install systems that monitor rainfall, soil moisture, ground movement that can provide timely alerts to the potential landslides. That's what we can do. I think for today I'm done. I'll do geomorphology for the other paper tomorrow. I will do the for the other paper tomorrow. Thank you so much and have a blessed day.